All right, quiz 2. Heptane. So 1, 2, 3, 4, 5, 6, 7, right? 7 carbons. You gotta have that number down. Carbon 2 is bromine. 3, 4, ethyl, methyl, right? I could come from a number from either way, but bromine's on carbon 2. There you go. To name these amines, find the nitrogen with the longest carbon chain. 1, 2, 3, 4, 5. Right? So that's a pentanamine. Then it has a 1, 2, 3. N-propyl, methyl, N-methyl, N-propyl, pentanamine. M before P. But you got to tell us, I said N twice. Longest parent chain is the cyclo. The rings are always the parent chain. So it's the cyclohexane. And it has 1, 2, 3, 4 methyls. So it's tetramethyl. And one of the lowest numbers possible. So we say 1, 1, 3, 3. Tetramethyl cyclohexane. So you got to show all 4. You got to give numbers for all 4 methyls. Resonance arrows. Again, bonds broken, bonds formed could have helped here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Think about which bonds are being formed and broken. There's a lone pair on carbon 1. It forms a new pi bond between 1 and 2. The pi bond between 2 and 3. And the 2 electrons in that pi bond end up on 3. The electrons on 3 then form a new pi bond between 3 and 4, breaking the pi bond between 4 and 5, right? Keeping track of those things, numbering those things, adding arrows where they need to be added. And then what's the most likely one? It's 1 because oxygen is the most electronegative. Everybody has full octets, all full octets, but then oxygen here is the most electronegative element, so that's the most likely to have a negative charge. All right, label the hybridization states for all the atoms. Right, for all the atoms except for hydrogens. sp3 hybridized, no pi bonds. sp2, 1 pi bond. sp3, no pi bonds. sp3, no pi bonds. sp2, 1 pi bond. And this nitrogen, because it has a lone pair and is next to a pi bond, it's going to be sp2. The hybrid orbital the lone pair is going to be in is a p orbital because it's going to be able to do resonance. Right, so it has to be a p orbital if it's going to do resonance. And what hybrid orbitals are making up the sigma bond between the starred carbon and nitrogen? The nitrogen's sp2 hybridized, so it's using sigma sp2 hybrid orbitals to make sigma bonds. This is sp3 hybridized, so it always uses sp3. So it's sp2, sp3. Which one have the lower boiling point? Right, this will have a lower boiling point. This can do hydrogen bonding, which is the strongest intermolecular force. It's not a real bond, right? When we boil or melt things, we don't actually break bonds. We disrupt intermolecular forces. So because this one has no H bonding, right, only dipole, and intermolecular forces, right, or London forces, it has the lower boiling point, right? Hydrogen bonding is the greatest intermolecular force, or the H force, as we like to call it now.